Hello, I'm Dwayne Shelton. I'd like to show you a sample of some slides that I used for a paper that I presented in Istanbul, Turkey, a year or two ago. The paper was on um, trying to figure out what was the cause and effect of high technology manufacturing. Was it caused by investments in R&D? Or was the investments a product of the high technology manufacturing? There's a standard statistical test called Granger causality that allows you to determine that, to see which direction the causality runs in and how strong it is. So take a look at the slides. The bottom line is that for some countries, the causality runs in one direction, that high technology manufacturing actually funds research and development. And in some other countries, it's the opposite, that it's the investments in research and development that causes high technology manufacturing. Thank you. This is a paper that I gave at a ISSI conference in Istanbul, Turkey, a few years ago. And it connects scientific indicators statistically to try to determine which one is the cause and which one is the effect, if there is that kind of causal relationship. My co-authors were Tarek Fidel and Patricia Folan from WTEC. Well, this is the classical linear model of innovation, starting with funding. Uh, you support research, um, initially basic research or fundamental research. The discoveries that come from that go into a process, the second process of applied research or development. The results of that are technologies that, if they're successful, can be manufactured either abroad or domestically and sold in the marketplace to produce income. And, you know, in studying research, we kind of lose sight of the fact that it's that sale of products or services that really is about the only way that research can pay for itself. So it's nice to carry the process all the way through to that phase, at least occasionally. Now, this is a simplified linear model, as I say. There are other paths between these boxes. There are other boxes. These are kind of simplified. But one path is that going all the way from the output products and services, that income can pay for basic and applied research. So strictly speaking, there should be a feedback path showing the influence of that um, income on the income process input processes. As an output, we're going to focus on high technology products because those are the ones that are most directly connected to research and development. And this graph shows the world share of high technology HT manufacturing. It has curves on here for the United States, European Union, the People's Republic of China, Japan, and Deutschland, Germany. And probably the most significant trend in this set of curves is the rising curve of the PRC. That's the one with the little up triangles denoting the curve. And since this is a world share, you would expect if one player is greatly increasing their share like that, then other players would tend to go down. Their share would tend to go down, and that's kind of what we see. The United States, European Union, certainly Japan, Um, their share is decreasing as China rises. The Germans, the bottom curve, have been able to fairly well hold their own in high technology manufacturing. In the past, I have used statistical correlation to connect indicators like manufacturing outputs or exports to input indicators like publications and patents or funding. But, you know, everyone knows that just because two variables are highly correlated doesn't necessarily mean that A causes B or B causes A. Sometimes you can argue that there is a logical connection, and here there is. Funding of research clearly causes research outputs like papers and patents. Every researcher knows that it takes money to do research and to travel to conferences like ISSI to present the results. But in other cases, the direction of causality is not so clear. As we saw in that linear model of the innovation process, sometimes the sales of high technology products at the output could actually provide feedback to fund the research that might otherwise be thought to be its cause. Um, well, there is a statistical test that sometimes can help determine whether there is causality or the direction of causality, and it's performed on a time series from a single country. The test was devised by a statistician named Clive Granger. He won the Nobel Prize for this and other work in the field. Uh, it is a relatively simple test in concept, um, but it's not a very powerful test, and that is it often fails, even when logically you might think that time series A causes time series B. The Granger test can't really prove that. Sometimes it does, and sometimes it uh, shows that the causality runs in the opposite direction from what you might think. Anyway, we're going to be talking about Granger testing of research causing high technology manufacturing here, and let's just review our prior work on this subject. Um, we've shown that the European Union passed the United States in papers in the mid 1990s, and we look for the cause of that, and we use correlation in that paper, and we showed that government investments in R&D were particularly effective in encouraging papers because they mostly go to universities. At the end of the Cold War, the U.S. mix of R&D funding shifted sharply from half government, half industry to one-third and two-thirds respectively. The EU did less of this shift, so this caused the United States to be less efficient than the European Union in producing papers. Um, and our paper then attributed this to the European Union passing the United States to take the world lead in scientific paper output. At the time, we argued this basically from correlations and, you know, the logical connection between funding and as an input and research as an output. Now, let's apply Granger testing to this to try to sharpen this conclusion and to illustrate Granger testing. Here's some time series that makes this easy to visualize. On top, you have what might be the cause of these trends. GERD is government, our government and private sector research and development funding. Um, this particular curve is just the government component. It shows the black curve is the United States and the Pink curve is the European Union. It shows, for example, the decline in the mid 1990s of U.S. R&D funding. That's the result of the ending of the Cold War. The Cold War had motivated a whole lot of military research and development, and when that went away, there was less incentive for the United States government to fund research and development, so there was an overall decline. The bottom graph shows the output papers in the Science Citation Index, SCI, and if you look closely, you see that the curves kind of mirror the GERD curves. That is, the output papers look a whole lot like the input funding, just delayed by a couple of years, which would think reasonable. Now, that's the general situation here. Let's apply a Granger statistical test to this to see if there really is a connection between these curves. Okay, sorry for the math here, but it's not too complicated. Um, what we're doing here is using the history of a time series, samples of its prior values, to predict the next value of the time series. The time series is y of t, t minus 1, t minus 2 are values of y in the past. And we use a linear formula for doing the prediction. We simply predict the present value of y by a linear combination of the prior values of y. Now, that's a standard way of doing forecasting. Okay, now to test whether a second time series, that's the x's in the second equation, could be used to improve that forecast, we simply have a linear formula for both the prior y's and the prior x's. Okay, then you try it and see if you get a better prediction. You do a standard statistical test to see if adding the second series data improves your prediction results by having a lower variance. There's this, so the Granger function, as built into the R statistical package, it's open source statistical software, was used here. Here's the results for the United States. In the first column there is a statistical test to see whether the United States government GERD, USGG, the FF means that you have to difference it twice in order to get a stationary time series, which is required for the Granger test. Does that cause the US paper second differenced variable? And the boldface type there indicates that the significance parameter P is less than the threshold value of 0.1, which is what we used here, for a model of two terms, k equal 2, from the input x variable. It's actually less than 0.05, which is a stricter test of statistical significance. In the right-hand column, we tested whether papers could be said to cause funding. That's a little bit more far-fetched, and not surprisingly, the statistical test says that the causality in that direction is not significant. Okay, so this supports our prior work, which was simply based on eyeballing those graphs that I showed you. They attributed the EU passing the United States in papers in the mid-1990s due to the U.S. shift in industrial funding of research. However, you notice that the European Union is not shown here, and the reason is that the Granger tests for those series were not significant. So that's what you get with Granger testing. It sometimes disappoints you that way. Okay, going back to correlations. Um, these show the correlation coefficients between high technology exports in the first column and overall high technology manufacturing in the second column. Uh, they're correlated with a bunch of different potential causes, like research as measured by papers or applied research measured by patents. Okay, so what's the difference between the two columns? Exports are measured on a cash basis. They're measured at the custom house at ports, and they just count the number of um, computers or whatever the products are that are being shipped from China to the United States. When Apple sends one of their computers or iPhones to the United States, uh, manufactured in China and sold in the United States, it's counted as an export for China. Okay, well, that's a little misleading because those products often have components in them that were manufactured elsewhere, not in China, but maybe even in the United States. Indeed, that is the case for many of Apple's products. That the key components are made in the United States or Japan. So counting the entire product as being from China as a high technology export is really kind of misleading. And so the second column attempts to correct for that. It measures exports on a value-added basis. It attempts to determine the percent of foreign-made components in a product like an Apple iPhone, and it credits those components to the source countries. So this is a more accurate way of measuring international trade. It's a new series that has been developed by the World Trade Organization and the OECD. And in fact, if you just scan down those two different columns, you find out that the correlations for this new and improved measure in the second column is actually always considerably higher than the correlation for the exports. So just this chart here shows you that this works better. Okay, we're going to use the second column. Um, I've written papers before, using the first column. But for the Istanbul paper, we use the second column, the value-added series, and we use this chart to select the input indicators that might be thought to be the cause of high technology manufacturing as an output. And if you just look down the second column, you see that Bird has the highest number in it. What is Bird? Well, that's R&D funding uh, spent in the business sector. Um, R&D funding is measured by OECD and broken down in a couple different ways, both by the source of the funding, government versus business, and also the place where the research is done. Is it done in government or business or universities or whatever? Uh, Bird is actually research that is funded by the business sector. And not surprisingly, As you see, it's got the highest correlation with high uh, technology manufacturing. Well, uh, so business does a better job of that than government or any of the other indicators as a predictor for high technology manufacturing. So we'll focus on bird. Here's another way of looking at that same thing. We've now focused on bird as a statistical cause for high technology manufacturing. And so we're shown a scattergram for the various countries of the OECD. There's about 43 of them. And so the standard scattergram and regression diagram shows uh, visually that there is a high correlation between these two variables. Both the y-axis and the x-axis use common logarithms to allow you to look at the wide range of these variables that you see from very small countries to very large countries. And it's very hard to see, but the point all the way up to the upper right is the United States, and all the way down to the left are countries like New Zealand is the one at the very bottom. Okay, so we applied the Granger test to this using the function built into the R uh, software. And these are the positive results that we got. Of the 43 countries, these were the ones where we got some significant results. The others were not significant. There's a fair number of them here. And we've shown the direction of causality in two directions. The first column is if manufacturing causes bird, and the second column is if bird causes manufacturing. And the boldface type shows the ones that are statistically significant using a p-value of less than zero point 0.1. Sometimes it's well less than zero point 0.1, showing a pretty strong connection. Um, and there are three countries at the top: Korea, Hungary, and Romania, where, and one at the bottom, where Finland, where yes, business expenditures in research and development do Granger cause high technology manufacturing. There's with a statistical significance. On the other hand, there are other countries, the ones in boldface type on the left, the People's Republic of China, Canada, Germany, Russia, and Finland, where the opposite is true. Manufacturing provides the funds for business expenditures in research and development. Actually, if you look on the bottom row, Finland has got boldface type in both columns, so it has bidirectional causality, and that's maybe gives you pause, but it's not so unreasonable that if you visualize a model of innovation, you can have a feedback loop where you don't have to have just flow in one direction. You can have flow in both directions. So that's not so bizarre. All right. Well, what about some traditional scientometric indicators? This conference, ISSI, is for scientometricians, and the indicators we've been using here, like BIRD, business expenditures in research and development, and high-tech manufacturing, are a little bit outside their scope. They like to talk about papers and patents and indicators like that. So let's at least bring in um, some traditional scientometrics indicators and to see if they might be good predictors for high technology manufacturing. Well, one that does shows some significant results is patents. This, of course, is not surprising. Patents are closely connected to applied research and closely connected to manufacturing of high technology products, and so it's not so surprising that if a country has lots of patents, then they might well produce lots of high technology manufacturing. And that's what this chart here shows. Uh, Patents in the first column, patents do Granger cause manufacturing in all of those countries on the left, European Union as a whole, all the way down to the Netherlands. Um, so that's reassuring. Of course, the OECD countries that are not on this list did not have significant results. So this is not just a sample. This is the whole set of significant countries. As you can see on the bottom two rows, Germany and the Netherlands have bidirectional causality, Granger causality. So does that make sense? It's reasonable that a country that has lots of patents will produce lots of high technology manufacturing, but perhaps it's not so unreasonable that if a country has a lot of income from high technology manufacturing, they might be able to support a lot of applied research and produce a lot of patents. So again, this bidirectional causality is not really so bizarre. All right, so here's the bottom line. This Granger test for causality can sometimes illuminate connections between scientific indicators. However, it's not a panacea. It often fails, even when you would expect one time series to be a cause of the second series. And again, you do have to detrend the series to make it stationary before you can apply the Granger test. You do that simply by taking differences. Um, Often you have to do that twice. You have to difference the data twice. Um, and finally, this new data from OECD and World Trade Organization on value-added manufacturing does provide some evidence that R&D funding and indicators like patents do produce national benefits that the public really cares about, jobs and the viability of a nation's high technology industries.